Okay, hello class. Today we will start with a new chapter, which is that amino acid, and this is the overview of amino acid. Note that we will only discuss C1 and C2 in lecture. And this is that the learning objective of amino acid, which you can have a look. So first, what is general structure of alpha amino acid? Amino acids are organic compounds that contain both amino group NH2 and carboxyl group, which is that COOH. Alpha amino acid is amino acid with the amino group and the carboxyl group both bonded to the alpha carbon next to the carboxyl group. So, what is the alpha carbon? The alpha carbon is the one that bonded to the functional group is called as alpha carbon. So in this case, why it is called that alpha amino acid? Because the alpha carbon is bonded to amino NH2 and also carboxyl, which is that carboxylic acid. And different G group will give the unique characteristic of the amino acid. Okay, let's move on to IUPAC nomenclature of amino acid. So take the carboxyl group as the parent and amino group as the substituent. So for the example here, so start numbering, start from the COOH, first, second, third, to the longer chain of carbon. So here we got 5, which will be pentanoic acid. And then the substituent will be 2-amino 4-methyl pentanoic acid, or known as leucine. And the symbol will be LEU. And continue with another example, still the same method. Start numbering from the COOH. So the longer chain here will be 3 carbon, which will be the propanoic acid. And then the substituent, amino and also phenyl. So the nomenclature, the name will be 2-amino 3-phenyl propanoic acid, or phenylalanine, the symbol PHE. And more example of neutral amino acid. The first one will be glycine, which is that the simplest amino acid because the G group is simply H. That will be 2-amino ethanoic acid. And the next example will be alanine, which the name will be 2-amino propanoic acid. Note that the G group here for alanine is CH3. So continue with another example of neutral amino acid, which will be threonine. The parent name is butanoic acid and plus the substituent. So it will be 2-amino 3-hydroxy butanoic acid. And the next neutral amino acid will be serine, which as you can see it here, the parent name is propanoic acid. So full will be 2-amino 3-hydroxy propanoic acid. Continue with acidic amino acid. First will be glutamic acid, which as you can see it here, that total we got 5 carbon as the longest chain and ended with 2 COH. So the parent name will be 5 carbon, so pentane dioic acid plus the substituent, so will be 2 amino pentane dioic acid. And the next example is aspartic acid, which it will be 2 amino butane dioic acid. So always look for the parent name and then you add the substituent, then we can get the full name according to IUPAC nomenclature of amino acid. And continue with basic amino acid, lysine, which, how many carbon here? So total here will be 6 carbon, and then you got 2 substituent of amino. So the parent name will be 2,6-diaminohexanoic acid. Okay, lysine. So here are the exercise which you can try, and then later you can check with the tutor. You can always pause the video and then try to do the exercise, and you can always ask your tutor for answer. Okay, then we move on to optically active of amino acid. So all amino acids are optically active except glycine, because as you can see from the structure of glycine, the G group is simply H. So there's no chiral carbon in glycine. That's why it is optically inactive. Whereas for other amino acid, like the alanine here, it is optically active because it got chiral center, which is a carbon that bonded to 4 different groups of carbon. And for optical activity enantiomers, all amino acids except glycine have chirality center, so they can rotate plane polarized like optically active compound. And each of the alpha amino acid exists as a pair of enantiomer. So enantiomer will be referred to the mirror image which is not superimposable. Like the example here, alanine, 2-amino propanoic acid. So they are a pair of mirror image which is not superimposable, meaning that they are different, 2 different molecules. So same thing here, the exercise that you can try. Then later you can check the answer with your tutor. And what is zwitterion? Amino acid can undergo internal acid-base reaction in which a proton is transferred from the carboxyl group to the amino group to form a dipolar ion called zwitterion. So as you know, the COH is the acid part, right? Which is able to donate a proton H+. And the NH2 is a basic part which that can accept a proton. So what happened here is that it can undergo internal acid-base reaction. The proton from COH is donate and transfer to the amino group. So it forms a structure like this, which we call as zwitterion. Zwitterion is a molecule with an overall charge of 0, which has an positively charged group at one part and a negatively charged at another. So this is the general formula for zwitterion of an amino acid, which as you can see that the carboxylic acid, the carboxyl group, right now after it donate the proton, so it become carboxylate ions. Whereas another part beginning is that NH2 amino group, after it accept proton, so it become ammonium cation. So this is similar to the statement just now for zwitterion. The dipolar nature of amino acid accounts for its unusually high melting point, high solubility in water, and amphoteric nature. So again, zwitterion is a molecule with a positive charge on one atom and a negative charge on another atom in the same molecule. So here are some examples of amino acid. For alanine, when it's uncharged structure, as you can see, there is COOH and NH2. And when it becomes zwitterion, the COOH right now is become CO minus carboxylic ion, and the NH2 right now will be NH3 positive. Followed by lysine, similar. So we just need to focus on the COH change to CO minus and the NH2 change to NH3 positive. Similar things for glutamate acid. So take note that here the changes is just that COH change to CO minus and NH2 change to NH3 positive. The rest of the structure is remain unchanged, still the same. And another thing is that what is isoelectric point? So in general, zwitterion is electrically neutral and exists at specific pH. And this particular pH is called isoelectric point. Isoelectric point is a pH at which the concentration of zwitterion of an amino acid in the solution is maximum. So take note that here each amino acid will be having its own specific pH, which they will exist as a zwitterion. So and zwitterion is amphoteric in nature. It acts as a base in the presence of an acid and acts as an acid in the presence of a base. So you can see that here. When is that zwitterion, it is neutral. When is that in basic medium, when it's in basic medium, the NH2 remain unchanged, but the COOH will be donate its proton because it is in basic medium. What will happen to acid in basic medium? The acid will try to donate each proton, isn't it? And on the left hand side, when amino acid in acidic medium, so right now the carboxyl group will be remain unchanged. Acid in acidic medium, no changes. But the base in acidic medium, it will play its role, which is that accept the proton. Okay, so that is the difference when zwitterion is placed in a basic medium or placed in a acidic medium. In aqueous solution, amino acid exists either as a zwitterion, a cation, or anion, or as an equilibrium mixture of these ions, depending on the pH of the solution. Here are some examples. We take alanine as an example. So when alanine is placed on acidic medium, so it will behave as a base. And as a base, it would accept the proton from the acidic medium. So oppositely, when you place alanine on basic medium, so it will behave as a acid right now. So as an acid, it will donate its proton. So as you can see it here, when you place in acid, then it will behave as a base. When you place alanine on basic medium, it will behave as a acid. So before this, I mentioned that for each amino acid will be having its own isoelectric point, which they will exist as a zwitterion. So for example, like glycine here, the isoelectric point is pH 6.0. So above 6.0 is considered basic for it. And when it's that below 6.0, it is considered acidic medium for the glycine. Okay, just like our prior knowledge, pH equals to 7, that is neutral. More than 7 is considered basic. Less than 7 is considered acidic. So apply the similar things here. It's just that using the isoelectric point for each amino acid. Like the example here, isoelectric point for glycine is 6.0. So above 6 is considered basic. And here are some exercise which you can try on. So as I suggest, you can always pause and then do the exercise. And here are the answer. So here are some more exercise which you can try it out and ask your tutor for answer. So similar things that here are more exercise.